Hi everyone. In this video we're going to talk about how we can use the side lengths of a triangle to figure out what some of the angles are. So I have an example here where I've got a right triangle, one side length is 2, one side length is 7, and I've got some angles here that I don't know yet, theta and beta. I'm going to try and figure those out. So what we're going to do here to start is I'm going to try to figure out what this hypotenuse is. So to do that, I'm going to use the Pythagorean theorem, which tells me 2 squared plus 7 squared is equal to c squared, where I'm going to call this c over here for right now. Okay. So on the left-hand side, 2 squared is 4, 7 squared is 49. So this gives me 4 plus 49 is 53 is equal to c squared. And so I get that c is equal to the square root of 53. So algebraically what you would get is plus or minus the square root of 53. But since we're talking about a length, this here is the positive side of it. So lengths are going to be positive. So I get 2, 7, and then my hypotenuse is the square root of 53. All right, so to figure out what theta and beta are, I just need to figure out what one of them is. So if I know what theta is, I know that if I add up these three angles, I'm going to get 180 degrees in my triangle. So I could either add or subtract to get the other one. So let's go ahead and choose theta here. And see if we can figure out what it is. So in order to do that, we are going to bring in some trig functions. I'm going to bring in the sine function and the tangent function here. I'll show you how to do it with both of them. You don't need both, you only need one, but it's always good to have more tools. So if I take sine of theta, I know that sine of theta is equal to the opposite side divided by the hypotenuse. And so sine of theta is going to be 7 divided by the square root of 53. And tangent of theta is going to be equal to the opposite over adjacent, which is 7 over 2. And so to figure out what theta is, we're going to use our inverse trig functions. So this tells me that theta has to be equal to arcsine of 7 over the square root of 53, or theta has to be equal to arctangent of 7 over 2. Okay, so these numbers are going to end up being the same thing. But in order to figure them out, what we're going to do is go ahead and plug them into Desmos to get numbers that make a little bit more sense to us. Right, so what I have down here is a Desmos window, and on the left-hand side, you can see that I've plugged in arctangent of 7 over 2, and I've plugged in arcsine of 7 over the square root of 53, and I get the same numbers here, 74.054. All right, if we round up, we could get 74.055. And so what this is telling me is that my angle has to be 74.05 degrees. So 74.05 degrees. One important thing to note is that you have to make sure that Desmos is in the appropriate radians or degrees. So default is Desmos to be in radians. So if you plug that in, you're going to get arctangent of 7 over 2 is 1.29, but that's radians. So if you want your answer in degrees, because to do our angle sum, we always think about it in degrees, 180 degrees. That's probably going to be the one you want most often. Right, so make sure that your calculator is there. So 74.05 degrees. Right, so we'll take this we'll come back up. Right? So come back up here at our Desmos window. So theta has to be 74.05 degrees. So let's go ahead and take this out. Let's put in our degree measure. So this is 74.05. Okay, so I have 90 degrees. I have 74.05 degrees. And then in order to make 180, the other degree that I need over here is, right, so think about it. If you had to pause the video here before I write it, this would be a good time to do that. What angle goes over there? So the answer is 15.95 degrees. Right, so this is how we find our angle measures. And so inverse trig functions help us out. And one important thing that just came to my mind was you may be asking yourself, well, what about the other values of theta that, that we could get? And so it turns out that inverse trig functions are nice because we know that these outputs are always going to be between negative pi over 2 and pi over 2, or between negative 90 degrees and positive 90 degrees. And since we're dealing with positive numbers here, positive side lengths, these numbers for the triangles are always going to be between 0 and 90 degrees, which is exactly what we want here. So we want these acute angles that are going to be given by our inverse trig functions. So they're particularly useful, no modifications needed. All right, so I hope this example helped out. I'll see you next time.